Hi everyone, good evening. Welcome in another session of AI/ML. So in the last session, we have gone ahead with the very basic sections of a neural network. Today we will be going and deeping dive into the detailed part of it. Okay, so let me just share my screen. Till yesterday, we have discussed this much, so we will just go here. So this is how a neural network exactly looks. So we'll just take a bit brief about what is neural network, what are layers, and then we will proceed so that we don't you don't fill any gap in between. The things come down in a continuation. Okay. So, what is a neural network? So, you can imagine that from your brain, brain has some of the tiny cells called neuron, right? So, this neurons receive the information, they think, and they give an answer, right? So, the neural network in the computer brain made of the neural network is a computer brain made by the humans, you can say. Okay, so it learns how to answer question like, is this photo is of cat or a dog? Is it a raining tomorrow? Is it like, is the message is for happy or sad, like that? Okay, so this is about neural network. Now what are layers, right? Layers and neural networks. So this are basically, you can see here in this image, there is input layer, hidden layer, outer layer. So output layer. So what are these layers? So you can think about a factory that makes chocolate, right? So what are the steps there? Like, you can find it out. Like, suppose for the layers, I am taking this example. So the layers for this, we are taking the example of factory, chocolate factory. Okay, chocolate factory. So what are the things that happen here? The very first one is raw cocoa comes in. Then it gets cleaned. Then what it does, it gets mixed. Next, then it becomes chocolate, right? There are other in detailed process of how chocolate is prepared from cocoa, but I'm not just not going in details of it. Every one of you know, like the cocoa beans are taken, grinded, like it's been dried under the sun. Then the other processes goes on and stuff. But initially, we just take this route, like the simple way. Okay, so the raw cocoa comes in, we clean it, we mix it, a chocolate is becoming like chocolate is formed, and then the chocolate comes out. Okay, so this happens in different steps. So each step is done in different by different person in different segments of room, right? So in neural network, each of this room is considered as one layer. So layers are steps where the network slowly thinks and understand the data. Okay. Now we have discussed about types of layers. So let's just go into types of layers. So the types of layers are input, then we have the hidden layer, and then we have the output layer. Okay, input, then we have the hidden, then we have the output layer. Now this input layer. So why it is we call this input layer our eyes and ears? Because that listens. Okay. What does it do? It takes the information from the outside world. For example, suppose let's teach a neural network to decide, right? So what we do, we should wear a jacket. Should I wear a jacket or not? Based on the temperature, right? So what would be my inputs up here? My inputs would be temperature. Next, coming down, is it windy? Next, is it raining? Like this of question, right? So what is my inputs up here? So we have x1, x2, x3. Already we have discussed all. Just for a reference, I am giving you the update. So the meaning is for this is temperature. Next we have, okay. Next what we have? Next we have the wind. Next we have the rain. Okay. So these are the steps. So these are just the numbers. Okay. So what is the temperature? Temperature is 10 degrees centigrade. Okay. 10 degree. This is degree and C is centigrade. Okay. 10 degrees centigrade. Coming down wind. Wind is suppose it is giving as yes. And then we have rain. Rain is giving as no. Okay. So the input layer does not think. The layer does it only passes numbers forward. It only passes the numbers forward. Okay. So hopefully the input layer is clear to you. Coming down to hidden layer. Okay. So what's about layer? Hidden layer, like this is the most important part. Why it is called hidden? Because we cannot see what it is thinking or what it is happening inside the hidden layer. Only my system or the computer knows about it. Okay. So what does a hidden layer do? Okay. What does a hidden layer do? So it first of all it receives the number from the hidden layer. Okay, sorry, it receives the number from the receives the number from the input layer. Then what it does, it multiplies the number. Okay, just a moment, guys. Let me just take this. Okay. So next we have multiplies the number. What it does then, and then it adds them. Then it decide how important they are. Okay. And now let's learn how it does. Okay, how it does. So we have already discussed about weight. I guess you remember about weight. So weight measures how important this input is. Okay. So suppose for temperature, I am taking the weight value of weight. Let's put it W weight. So this is suppose 0.8 because my temperature is a very important factor for me to wear the jacket, right? So I'm taking it as 0.8. Now about wind. Wind is a less important. There is no such importance about wind for wearing a jacket. So I'll just take it as zero point 0.3. About rain, we can think about zero point 0.5. If there is rain, the weather is a bit, the temperature is a bit lesser, so I might need a jacket, right? So that is the idea. Now, how we are doing the multiplication, how we are taking it. So we are just taking input. Next, we have the weight. Then we have, just a moment, let me just fix this line. Yes. Input weight. Then we have, before that, I'll take the values, control X, control V. Okay, control X, control V. Here, I'll take the values. And then we have the multiplication. So I'll just put a star up here and then we will be taking it all together. Okay. So this is the idea, moreover. So input is X1, that is temperature. Next we have X2, that is wind. Next, we have X3, that is rain. Okay. So these are all about it. Now about coming down values. So values first we have suppose the value of where we have taken it. Yes, 10, 10 degrees centigrade temperature, wind, we are saying yes. So it will be converted to 1 because my system understands the binary numbers better. So we will be just converting it to 1 or 0. Okay, rain is no, so we are converting it to 0. Okay, now weight is 0.8, 0.3 and 0.5 like that. Now if I am multiplying it, 10 into 0.8 gives the value as 8. Now 1 into 0.3 gives the value as 0.3. Now 0 into 0.5 gives the value as 0. Okay. Now I want to add everything. So after adding, like we need to add 8 and 0.3. That is my additional value would be 8.3. Okay. After I have added all these values, my result would be 8.3, right? So this value is called weighted sum. What it's called? Weighted sum. Okay. Now coming down to bias. Bias is basically extra motivation, as you all know. So we'll take the value that I have already explained. So you can just check the previous one. So I take the value of B as 1, then I'll do weighted sum WS plus B. So the value will be 8.3 plus 1. So it will come out as 9.3. Right? Now what I'll be doing taking activating function. Okay, I'll be taking the activation function. Now here activation is the decision maker. Is it yes or no? So I'll take the threshold value as okay. So if the value is greater than 5, then yes. If lesser than 5, then no. Right? So I got the value 9.3. Right? So the value that is 9.3 is greater than 5, of course. So it would be yes. My result would be yes. So I need to wear a jacket. If in any case my weighted sum plus b, this function, this value is lesser than ws plus b, if that is lesser than 5, my like that is threshold, then my result would be no. Okay. So this is how I just take the details. So this I have already explained. Now coming down to the output layer. Okay. Output layer, what is that? This is the answer giver. Okay. So this layer gives the final answer. Okay. This layer gives the final answer. Okay. So for example, like jacket, should I wear it? Not wear it. Emotion, how is it? Happy, sad, angry. Image, is it a cat or a dog? So we can expect the output as 0 or 1, or we can get the probabilities. How we can get the probabilities? Like if it is suppose a cat, I'll get the probability as 0.8. Okay. Now coming down, if it is a dog, I'll get the probability as 0.2, like that. So this is how my probability will come. So probability for the image to be cat is 0.8, for the image to be dog is 0.2. Okay, that means the probability of cat is going more. So the image would be of a cat. So this is how it will work. Now, how does the neural network learn? How the training happens? So from here, we are just taking it forward. So how the networks learn and how the training happens. Okay. So here, the very first step, step one is guess. Okay, so the network makes a prediction. Okay, the network makes a prediction. That is the guess. So suppose network says wear jacket. Okay, so I'll get the answer as yes, right? So after that, what will I do? Like, what will the network do? It will check the answer. Okay, just a moment. Just a moment, guys. Okay, just a minute. It has stuck somewhere. So, okay, fine. So we have taken it now. Now we will just increase the length. So we have increased it, no issues. Now basically we need to just fix the details. Just a moment for that. Yeah. Okay. Now the network says wear a jacket. That is yes. Right. Now what I'll do, I'll check my answer. What I'll do, check my answer. Okay. So suppose the correct answer is yes, and you have also predicted that is yes. Right. So correct answer is yes. Prediction is also yes. Right. So now what we are doing that is yes, that my model has performed well. My model has given a correct answer. So this is good, right? This is good because what I wanted from my model to do, my model has done the same. So my model has at the end predicted the correct answer, right? Then in that case, it's good. This is rewarding for the model. Like this is the model has gone it good, right? Now, if it is wrong, if wrong, in that case, what happens? We have to take the we have to make the learning happen. Okay, so then the learning happens. Okay, so how the learning happens? We calculate the error. What we do, we calculate the error. So what is the error? Already discussed in last few sessions. I guess by now you all know what is the error. Error is basically the actual result minus predicted. So correct answer minus the predicted answer. Okay. Suppose I have got the error. Like how is my error? Suppose error is coming up. I have presented like my correct answer was 1, but I have predicted 0. So my prediction, like what is the error that I am getting? That is 1. Okay. So this is how it is taking, right? So we have calculated the error. Now what happens? We'll go down to back propagation. Back propagation, that is backtracking. Back propagation. That is learning from mistake. What is it? Learning from mistake. Learning from mistakes. So this is a big word, but we need to understand about it, right? So we will be going back and fixing the mistake. This is the idea. Backtracking, like suppose we are doing any of the mathematical calculations. You all aware about this calculus. You all have done it, right? Calculus. Then you have done the derivatives, right? So you need utmost concentration when you are doing those problems, right? Suppose you have given the problem, one problem, you have solved it, you have mentioned everything in every step, and finally you got the answer. But when you are checking the actual or the correct answer, you are getting that your answer doesn't match the actual answer, right? Right? In that case, what you do, you just backtrack yourself. You just go in the previous step, the last to last step, then the step before that, and cross check everything. If you have done any mistake or wrong, if any mathematical operation you meant like you have done incorrectly, that's why you are getting this error, right? So you backtrack yourself, right? You backtrack yourself. The same thing happens here. So that is why we are calling it back propagation. So it goes backward and fixes the mistake. Okay. So now the network, what it does in the back propagation, the network actually adjusts the weight. The network, first one, adjusts the weight. Next, what it does, it adjusts the bias. Next, tries to reduce the error, because here we are getting the error is 1, and I have my correct answer is 1, by my predicted answer is 0. So I am getting the error as 1. But what would be my intention? My intention is to keep the error value very, very less. Okay. So I want to make the error equal to 0. So this is my intention. So now my error is 1. I want to make it 0. So if I want to make it 0, my error wants to make it 0. My actual answer is 1. That I can't change. That I can't change. What I can change is my predicted answer, right? I can change my predicted answer. So I can change my prediction from 0 to 1 by adjusting the weight, by adjusting the bias, right? This what I can do, right? And then I'll get at the end, my error value will come up 0. This is my intention and I want to do this, right? So this is how things are taking accordingly. So backpropagation is learning from mistake, that is from the network. So we adjust the weight and we adjust the bias, and we try to reduce the weight. No, sorry, we try to reduce the error. Sorry, really sorry. Try to reduce the error. Okay, so this is basically my intention. Now I want to predict, like how I am predicting. So, like predicting the maths, right? Wrong answer, that means I am learning, trying again, and improving. This is how it's work. So, I am learning, then based on that, I am trying again, then I am improving. The things move on going till the point I am not getting my error value 0 or very, very minimum, right? So now after this, it repeats itself. What it does, it repeats itself. So repeats means the network tries, now it fails, of course, now it learns, then again improves. This is the life, exactly in life how we learn anything. The same way has been mimicked in case of a neural network so that they can also learn, right? So this is how it works. Okay. So now we will go ahead with this deep neural network. So if a neural network has, suppose, let's just write it up here. If this neural network has one hidden layer, we call it a simple neural network. Okay. If it contains many hidden layers, then we call it a deep neural network. Okay. What we call it? We call it a deep neural network. Okay. So deep neural network. So basically, if one hidden layer, that is simple neural network. Coming down to the second point, that is many hidden layers, that comes down with a deep neural network. Okay. So this is the idea. Now more the layers, more is the thinking power. That is more layer, more thinking power. Okay. So this is how it moves. Now coming down where it is used, where the neural network used. So it is used in case of face recognition. In case of face recognition, in case of self-driven cars. Okay. Where else it is used in case of any of the chatbot, we are using it. Okay. So this is how things are moving. So input layer takes the data, hidden layer thinks and learn, output layer gives the answer. Okay. I'm just writing this for you so that it's clear for you people. So input layer, that is, takes the data. Next, we have the hidden layer, that is, that thing can learn. Next, we have the output layer, that is, gives the answer. Okay, it gives the answer. So how we have done the mathematical operation, that also I'm just trying to explain you once more so that things are everything is clear for you. So we are taking input into weight plus bias. Then we are going for activation function. Then what we are going? Then we are going for output. Okay. So coming down to the learning, how it starts? It starts from a guess. Then we go for Then we go for error. Then we fix the error. Try to fix the error. Then we have to repeat it until my system is learning accurately. My neural network is learning accurately. Okay. So this is all about the neural networks. Now we will be going down and understanding about the layers in a more details, somewhat like just wanted to give you an idea. So layers are just like the floors in the uh, in the in the building, you can say, right? So top floor would be my outer layer, the middle floor would be my hidden layer, that is the thinking layer, and the ground floor is the input layer, that is the information. Okay, so top floor, that is basically my output layer, that is the final answer. Okay, so basically how it goes when from one neuron we are moving to the second one. So all of this, the information is taken in the input layer. Okay, then whatever be the thinking, what is this thresholding part and stuff is done in the hidden layer. Output layer does just take the answer and take it down to the output layer. Now, when it transfer it to the next hidden layer, the output result is being taken by the input layer, then again the final decision is been made, like thresholding and overall thinking is happened in hidden layer, then we get the exact result in the output layer. So this is how the chain is growing and performing. Okay, so as I mentioned, the top floor is the output layer, that is the final answer. Then we go down to the middle layer, that is the middle floor. So that is my hidden layer, that is the thinking layer. Okay. Next, what we have? Next, we have the ground floor. So that is basically my input layer. Sorry, guys. So that is basically my information taking place. Okay. Now, how the information moves? It enters from the ground floor, goes down floor by floor accordingly, and comes down as an answer at the top floor. So this is how my neural network actually thinks. Okay. So now coming down, why do we need this layers? And one neuron is not enough, right? That is the question. So the thing is, when we have only single neuron, it cannot take it that way, right? One neuron can only multiply, add, and decide yes and no. That's all. But many neurons together, organized in layer, can understand the pattern, learn from the mistake, recognizes the images, voice, emotion, all. Right? So this is about the why we need this much of layers. Now coming down with the steps. Like suppose for humans, how we learned. So for suppose step one was understanding the letters. Letters basically alphabets. A, B, C, this alphabet we have understood. Next, what is the next step? Next step is understanding and writing words like cat, dog, cup. We have understood the smallest words first, then equally going down for the long words or larger words, right? Then the third step is the sentence. So that is like from alphabets going down to words, then going down to sentence. So suppose the letter wise I have learned A, B, C, D, then I have learned to write and read about cat, then I understood how to frame a sentence. A cat is sleeping. This is the sentence that I have prepared from the alphabet that we have gone in. So network actually learns the same way. So each layer learns one level of understanding. Okay. So accordingly, it will move. Okay. Now coming down to the example, suppose we have like about the input layer. If I need to give you the example, so how does the input layer do? It takes the information from the real world, convert it into numbers, send it to the next layer. This is what my the work of the input layer. Right now, let's take an example. My example is like, let's take it here. It's like fruit identification or fruit recognition. fruit recognition, right? So I want to recognize the fruit. Now I need to teach my system to identify the fruit. Okay. So what I'll be having features. Okay, just control C. Basically, here I need to go features, feature. Next, we will be going down for meaning. Next, I'll go down to for value. Okay, so this is how it will work. Okay, so feature is suppose color. Okay, so suppose on my fruit basket, I have red 1 and yellow that is 0. Okay, the value is what? 1. Okay, coming down to shape, that is coming around round, that is equal to 1, long, that is 0. Okay, so what is the value? It's 1. Now I have weight. Weight is like heavy, that is equal to 1, and light, that is equal to 0. And the value is 0. That means it is light. Okay, so color is red, shape is round, weight is lighter. Okay, so my input layers give this value forward, like just transfer this value forward, 1 comma 1 comma 0, right? So this is the data that goes in. So each number goes into one neuron, and each neuron hold one fact. Okay, this is how it will move. Now, in the example of an image, suppose I am taking the example of image. Okay, so now an image is just like the tiny dots called the pixels. All you know that each image is formed of pixels, right? So now what happened? The white pixels are bigger number, dark pixels are smaller number. Okay. Now suppose if I have an image that is 28 cross 28, then of course what I'll be having 784 pixels, right? So input layer has 784 neuron, and each neuron is equal to 1 pixel value. Sorry guys. So input layer will contain 784 neurons, and we have each neuron in 1 pixel. 1 pixel value. To be very specific, right? So this is how it will move, right? I guess you have understood about it. Now we are just going ahead and understanding how, if I am just getting the values like that, how it will be forming, but like how the operation will be taking. So 1 comma 1 comma 0. This is how my values are, right? Now suppose the weights. So these are weights. I am just calling it as W. Okay. So now my weights are coming as 0.5 comma 0.3 comma 0.2, right? So this is how my weights will come. Now I have the bias. Suppose I am taking the bias as 0.1. Okay. Now what I'll do, I'll just take the multiplication. This 1 into 0.5, that is 1 into 0.5, plus I'll be doing 1 into 0.3, plus, sorry, plus I'll be doing 0 into 0.2, right? So what at the end, what I'll get 0.5 plus 0.3, right? So my value is 0.8, right? Now what I'll do, I'll add the bias. Bias is 0.1, so 0.8 plus 0.1 gives me 0.9, right? So this is how it happens. Now coming down to the activation function, that is the main decision maker. So the activation function asks, is this number important enough? That is what it asks, right? So basically how it will take, so if number is greater than, suppose my threshold I am taking 0.5, then I'll get yes, else no. Okay. Now checking this, basically 0.9 is greater than 0.5. So I'll get the answer as yes. So now in the output layer, it will pass me the result as 1. Okay. So this is what it happens. Now come down with an example of uh, suppose any of the image recognition, like a cat image recognition. Cat image recognition. Okay. So the hidden layers one work like the first one is hidden layer 1. Okay, so what it will do, it will find the edges and lines. Next, coming down to the second point, so it will, the hidden layer 2. So what it will do, it will find the eyes, ears, nose, like that. Like that. Coming down to the third step, that is the third hidden layer. Okay, so what it will do, it will find the full cat face. Okay, so each layer builds on the previous one, right? If this needs to be found out, that each layer builds on the previous one. So the network, this is how the network actually works and understands. Okay, so now coming down, as we have already discussed, so simple neural network contains one hidden layer. Coming down, any of the medium neural network that contains 2 to 3 hidden layers. About deep neural network, that contains 10 plus hidden layers. Okay, so this is how it actually works. Okay, so now we'll discuss about some of the like what is the example of a multi-class example that we will be taking. So basically, this is how it will be taking, like which animal is this? If this kind of example I am taking. So in that case, of course, I'll get the output. My output will be coming out as suppose 0.1, comma 0.8, comma 0.1, like this. If my output is coming, that means cat is 80%. Next I have dog, that is coming as 10%. Next suppose rabbit, that is coming also as 10%. Okay, so in that case, if my output is like this, so it is totally based on the probability. Okay, so this is how it actually works. Now the networks learn how the networks learn. It compares the answer, calculates the error, sends the error backward, fixes the weight. This is what it does. That is back propagation that we already discussed, right? So this is all about this stuff. Now, if I need to just give you a proper idea about back propagation, then how it works. Now let's discuss about propagation, back propagation. Okay. So back propagation is basically like it's a single word. There is no space in between. So back propagation means learning from mistake and fixing them. Okay. Learning from mistake and fixing them. The steps that I have told, the same way it follows, like it goes for hidden input, hidden, then output. So one input, one hidden neuron, then one output neuron. This is how it actually moves. Okay. Now suppose we have taken the initial values or the starting point like that. Okay. Let's just take the starting point like that. Okay. For before that, we have to again just take it like that. Just a moment. Okay, and what else? This one. Fine. So now, what we are doing, so the problem we want to solve here, suppose we want the network to learn certain rules. Suppose, what is the rule? If, suppose my input is 1, then the output should be 1. This is the problem we want to solve. Okay, so this is like input that is equal to on. So my output is coming down as yes. Okay. Now coming down to the initial value. So we must start from somewhere. So we are choosing some of the small numbers. Okay. So we are taking input that is suppose x and we are taking it as 1. Next we are taking weight that is w1. That is we are taking it as suppose a zero 0.5. Next we have bias. The value I am taking as b or b1 and I am getting the value as 0. Next, I am taking the same, the weight 2 that I am getting as suppose zero 0.5 only. And the bias also I'll take the same. Here I'll just add B2. Okay. So now I'll make you understand about forward propagation. That is going forward. What is forward propagation? Forward propagation that is going forward. Okay, so basically, what happens? Let the neurons try to answer. That is the first step. That is the guessing part. Okay, so what is the output? Output is basically input into weight plus the bias. Right? This is how it works. So suppose like the hidden layer output, the hidden output. So that is coming out as zero 0.5 into zero 0.5 that is coming plus 0. Okay, this is what is my hidden output. So the result is coming out as zero 0.5. Sorry, this is not 0.1 because input I am taking 1. Sorry, this is 0. This is 1. So 1 into zero 0.5, my result would be coming out as zero 0.5. Okay. So now the outer neuron calculation, so that is coming out as, here my value is 0.5. So 0.5 into weight, that is weight 2. So into 0.5 that I am taking plus the bias value I am taking, B2 value. Okay. So my final output for this would be 0.25. Okay. Now what we are going? We are going for checking the mistake. Suppose the target or the actual value is equal to 1 and my prediction, that is equal to 0.25. Right. Now coming down to the error formula. So my error, that is coming out 1 minus 0.25. So that is equal to 0.75. This is my error. Okay, so the network is wrong, so it has to learn because the error is going as 0.75. So we have to go backward, we have to fix the weight little by little and need to go ahead. Okay, here comes the concept of learning rate. Here comes the concept of learning rate. So learning rate is how fast should my model learn? How fast should my model run or learn? Okay. How fast should the model learn? Okay. So this is the idea. So suppose I am taking the learning rate as 0 point. We can't take my learning rate too high and we can't just take it too small. So I need to take a value accordingly by which my model will be learning. Okay. So for this case, I am taking my learning rate as 0.1. Okay. Now I need to fix the output weight. What is my output weight? That I need to fix. Now I need to update the weight. So I'll get update the weight. So I'll get the new weight value. So I'll get new weight that would be equal to old weight plus what I am doing? I am doing error into learning rate. Okay. So this is how it will work. Got it, guys? So basically, we will be taking. Suppose here we have W2, right? W2 I need to update because W2, the learning rate 0.5 that comes down for this one is the output. Like this is the outer output, outer layer output basically. Okay, so this is what we are getting. This is coming for outer neuron calculation. This is basically outer neuron calculation. As we have two weights, two bias, so there are two neurons with the weights with specific different weights. So this is the outer neuron calculation that we have done. Okay. Now basically new weight equals to old weight plus error into learning rate. So now we need to just take it forward like that. We need to fix it. So W2 is 0.5 initially that we have taken, right? So my updated W2 value that will come as 0.5 plus I will be doing 0.75 into 0.1. Okay, so that is what I am doing. So here if I am doing the calculation, that is coming up 0.5 plus doing 0.075 because 0.75 into 0.1. So there should be three gaps, like three values after the decimal. So we are getting 0.075, right? So my updated value is coming out as 0.575. So this is my updated, like, okay, sorry. So here basically what we have done 0.5 plus 0.75 we have done, and we have got the value as 0.57575, right? This is what we have done. Now my output weight is now better, right? My output weight is now better. Now I need to fix the hidden layer weight, my hidden layer weight. So this is also 0.5. So this is the output layer weight and this is the hidden layer weight. Wait, that is coming out as W1. So I need updated W1, right? This is what I need. So for that, I'll be doing 0.5 plus I'll be doing 0.75 into uh, the value of learning rate we have taken 0.1. So this is what we will be doing, right? So here basically how it will be taking the same way. So here my values are quite same. So my updated W1 value is coming out as 0.575. Okay, so I am trying it once more with the updated value, like the hidden neuron again and the hidden neuron output. So I am just trying this work I am doing again with the updated weights. Okay, so the hidden output is coming as 1 into, because my input is 1, 0.575 that is coming, and the output is coming as 0.575. Right. Now my output neuron, I will be checking for output layer neuron basically. So here what happens, I need to just multiply this value 0.575 with the weight, with the updated weight. So that is 0.575 into 0.575, right? So my value is coming approximately around 0.33, right? My updated weight is coming out as 0.33, right? So now you can check my target value was 0.1 and prediction was 0.25. The error has came up as 0.75, right? Now what I need to do, I need to do 1 minus 0.33, right? So I get the value as 0.67. So now you can see my error value has decreased, right? I need to keep on going with the steps till the point I am not getting the lesser value, very less value of the error, right? So this is the case. Okay. Now the result wise comparison, if I am doing as I mentioned, so initially in the first time I am getting the error that is 0.25, and after learning it has got updated it, and now the error value I am getting that is 0.33. So the answer has improved, right? The error has learned, like my network has learned accurately, but it needs to be repeated till the point I am not getting the best result, right? So need to be repeated many times, need to be repeated many times. So we have started with the guess. Next, we have gone with checking the error. Then we have gone ahead with fixing the weight. Then we have gone ahead and try and repeat. Okay, so what I wanted to do after learning, my value come up as 0.33. Then in the next try, it will be becoming a bit more better. Let me see around 0.5. Then in the next try, it will come out as 0.7, right? Then it will come out around 0.9. right? Then at some point I'll get the result as 1. That is perfect, right? So this is what we wanted. So what is really happening inside, right? So in the back propagation, it finds where the mistake can come from, fixes the mistake altogether, like it finds where the mistake comes from, fixes each weight a little, and makes the network smarter over time. Okay, so this is how we are taking it further. Again, I am just giving the complete backward propagation or backtracking flow. So that is back propagation flow. I am giving to you once more so that you understand it accordingly. First one is taking input. Second one is okay. First one, okay. Somehow it has deleted the. Just a moment. Take input or taking input, whatever, the same thing. The second point comes out around for go forward, like forward propagation, that is predict. Okay. Then what we are doing, we are just comparing with the correct answer. Then what we are doing, fourth, calculating the error. Fifth one is going backward. Sixth step is fixing the weight, that is updating the weight. Then we are going for repeating the process. Okay, so this is how we are going in further. Okay, this is all about the back propagation. Back propagation is learning from mistake. Error is target minus prediction. New weight equals to old weight plus error into learning date. Okay, so this is all about the learning, the back propagation going ahead. Okay, now coming down to perceptron. What is perceptron? So this image is basically of a perceptron, the one that we have already discussed. So what is perceptron? So perceptron is a tiny decision-making machine. It looks as like at some point I want to get the decision like yes or no, on and off, 0 or 1. So that in that case, we are using perceptron. Like suppose if the things we want to check, like should I carry an umbrella? Is it cloudy? Like on what basis it will go? Is it cloudy? Is it windy? Is it raining? Like that. Okay. So basically the same thing here. We go for input. Then we have the weight. Then we need to go for the summation, like the weighted sum we are doing. And then we are going for the activation function and finally the output. The same way the inputs are coming, then we are going for the weights, that is the importance, how important which important inputs are more important. So based on that, I am assigning a specific weight. Then I am multiplying and adding accordingly. And then we are adding the bias. So as you know, the extra push that we are taking it. So we are adding the bias accordingly, and the bias we can take it in negative, positive, whatever we want. Then we are going for the activation function, that is the decision making part of it. Then we are going for completing the percepting part of it, like the after activation function we are getting a threshold. So based on that we are getting a output. Right. So basically, in the output, I will get x1 w1 plus x2 w2 plus x3 w3 plus bias taken into the activation function. Okay. So this is about the perceptron. So perceptron actually learns the similar way. It's like learns just like a student, answering the question, checking the answer, fixing the mistake, and also learning again. The same way the weights are updated, that is new weight equals to old weight plus learning rate into error, plus into input we are doing in certain case, but majorly we can take it or we can't take it also. Basically we can do it in some cases, because that is how the weights are getting updated. Okay, so my perceptron wise the formula is coming out: new weight equals to old weight plus learning rate into error into input. Okay, where we have taken it. Yeah. So here basically how we have taken it. So here we basically have taken it based on this area. So in case of perceptron, for updating the weight, we are just taking it further one more step. Basically, into input we are just doing. Okay. So the same thing we are doing, but just we are just taking it with the input. Okay, so this is how the things are moving in case of perceptron. And then we are finding the error, that is actual output minus predicted output, and things are moving like that. Okay, now suppose I am just taking a problem. Okay, let's just move in this zone. Yes, fine. So suppose I am taking as x1, taking x2, and taking output. Okay, so this is how I am taking the values. So suppose I am taking here 1 1 0 0 like that. Here I am taking 1 0 1 0. Output I am taking as 1 0 0 0 like that. Okay, and I am taking W1, that is 0.2. I am taking W2, that is 0.2. I am taking bias, that is 0 - 0.3. Let me check it with minus this time. And learning rate, that I am taking as 0.1. Okay. Now basically my values for the input, it is x1, and then we are getting it round as x2 equals to 0. x1 1, x2 0, target is 0. Okay. Target is 0. So I am taking x1 equals to 1, x2 equal to 0, like that is for this one, and my target is 0. Sorry, x1 equals to 1, x2 equal to 0, target equal to 0. Okay, now I am going for predict, that is going sum, that we are doing as 1 into 0.2, because my weight value is 0.2, plus I am doing 0 into 0.2 with the bias, plus bias, that is minus 0.3. So my sum is coming out as minus 0.1. The value I am getting as minus 0.1. So the output is equal to 0, right? Because I am going, my output is 0. Now the error I am checking, that is my target was 0, my output is 0. My output is 0, so I am getting the value as 0. So no mistake, there is nothing to change. Now I am taking another input. So x1 equal to 1, x2 equal to 1, and target is equal to 1. Okay, now I am doing sum. So what I am doing here, I am doing 1 into 0.2, plus I am doing 1 into 0.2 minus 0.3, that I am doing. So here my sum value will come up as 0.1, not minus 0.1, as positive 0.1. So my output is 1. Okay. So my output is 1. So here, suppose my threshold is the threshold or the activation function that I am taking. If the value is lesser than 0, then I am going for the output as 0. If the value is above 0, then I am taking the output as 1. Okay. So this is also correct answer because my target is 1 and output is 1. So we need to just keep on doing it. Okay. So perceptron is basically single neuron. It takes input, multiplies by weight, add bias, applied the step function or the activation function and gives the output. And in the learning case, it have in many mistake, it fixes the weight or updates the weight and improves. Okay. So this is about perceptron. Okay. Perceptron is a single neuron. Perceptron is single neuron. Steps I am one more time I am telling. Steps is taking input, next multiplying it with weight, next third step is adding the bias, next fourth step is applying the functions, step function, applying step function, that is the activation one. Then what happens? What we are doing here, just a moment. 5.5, it is giving the output. This is how it is going. And for the learning, we are going for mistake. Then it is moving down for fixing or updating. Weights, and we are improving. Okay. So this is how it is taking. Already discussed about in details how the things are moving. We're in perceptron learning rule. Perceptron learning rule that we need to understand. For that, what we are doing, new weight that is equal to old weight plus learning rate, into error into what I am doing. I am doing input. Okay. So this is the new weight. Then what we are doing, we are taking the error. What is the error? That is the actual output minus the predicted output. Okay. So this is all about the perceptron. Okay. So in the next session, we will be going ahead and in details, we will be learning about the different activation functions and the different types of neural networks. Like the simple neural network, we have already understood. We have understood about perceptron. Next, we will be understanding about CNN and RNN that we will be understanding and eventually we'll be moving ahead. Okay, guys. Thank you everyone for connecting in today's session. We will be connecting in the next session accordingly and completing this part. Okay. So thank you everyone. Bye.